In this video, we're given a quadratic function and we're asked to find its minimum. And in context here, we're asked to find minimum cost. So we're given that the cost of producing something is given by the function c of x equals 200,000 minus 135x plus 0.045x squared. And the x in this problem is representing how many units have been produced. It's asking us how many items should be produced in order to minimize the costs, and then what is the minimum cost. We're given a quadratic function here, so we know that the vertex will give us what we're interested in, maximum or minimum wise, but since it's a positive coefficient on the x squared, the vertex here really will give you a minimum. So we'll do the same thing that we've done before. We'll put this in standard form and get the coordinates of the vertex. So first step here, just rearranging these with the descending order of degree terms. We need to factor off the coefficient and the x squared. So I need to pull off a 0.045. Well, if I'm pulling off this coefficient, that means really to figure out the coefficient on the x here, we'll take the 135 and we'll divide by 0.045. Remember, if I take the 3,000 times the 0.045, I better get 135. Right? So the 3,000 is coming from the fact that we're taking the 135 and dividing by 0.045. To complete the square, we will take half the coefficient, which is 1,500, and square it. But again, this is inside the parentheses, so really this 1,500 squared is being multiplied by the 0.045. So we need to counteract that by subtracting 0.045 times the 1,500 squared. Now let's simplify. This factors as x minus 1,500 squared. And this arithmetic here will simplify to 98,750. So now we can read the coordinates of the vertex straight off. They are 1,500 and 98,750. We know that we're finding a minimum here. So as far as the problem goes for interpretation, the x coordinate is how many units are being produced. So 1,500 items should be produced. And the cost is the output of the cost function. So our minimum cost is $98,750.